Yeah, morning everyone. Today we'll start heaps, right? We will be doing heaps, and it's actually really important, really very important topic right now. It is very important because these questions are asked mainly asked in in the coding interviews. I mean, not in the online, basically not in the online coding rounds, but also in the technical interview rounds. Mean it has happened that like companies like Amazon, uh, and Amazon, right? And also Google has asked questions related to heaps, and just because it is asked in these companies and then you should do heaps, that should not be the only motivation. Your motivation should be that how heaps helps you to basically solve your problems in a more optimized way. So basically it helps, like it is it you know it helps to uh, make your solutions more optimized. We will see that, right? So let's just start, right? Let's just get into this. So I will be referring heaps using stacks here, right? Okay, I mean, just for the visualization purpose, this is the stack. See, like this is the stack, right? We will be considering this as a heap. Fine, this will be a heap, which will have some size, which I will be denoting with k size, right? And we will learn, like today we will learn like uh, identification to for checking if question needs heaps or not, right? We will be doing this, and yeah. So basically coming to, and then we will do questions. So coming to identification first, right? identification Identification, how do you, like how one can actually identify how basically you can apply heap to any question, right? So there are two things you need to identify. Like if there are these two things in the question, most probably you will, I mean, no, not most probably, 100% there will be the case that heaps will be there. So if the question has k, some kind of a k term, right? like let's say that you need to basically sort first k arrays, or you need to tell some largest kth element, right? Kth, then you can use heaps. And if the question also demands if it's smallest or largest, if the question demands something like you find smallest or largest kth, like basically both these, if the question has both these, right, then heaps will be applied, right? Heaps, you will identify that heaps will be applied, right? So this is the whole point. If the question has these two terms, you will just apply heaps. This is a shortcut for you guys, right? And also one more thing you need to basically keep a note of this as well. Like if there's k plus basically, okay, before this I will also tell something about heaps as well. Like now which heap to choose, basically there are two types of heaps, right? So we will say which heap to choose. Like once you have identified that the question will need heaps, right, then you will choose which heaps to, basically which heap to choose, right? So just hold on. Yeah, so basically again there are two types of heaps. One is min heap min heap and one is max heap. We will see what exactly these mean in some time, but yeah, basically these two are the main min heaps, types of heaps. And now which heap to choose. So for this we have like a shortcut I will provide you, right? So if question has k plus, if the question has smallest, like if you need to find something smallest, then apply max heap, right? And if question has k but it has largest, it asks for largest, then apply min heap, right? So please make a note of it. It's like we will also see, like you don't need to exactly remember this, but keeping this in the mind will, you know, make your solve it, like make your speed a little faster. So we will also see why this is the case, but yeah, this is a good point of, you know, making a note of it. So please note, right? Please note. Yeah. So this is done, right? Now we will see how to apply, right? Like let's say now we will just jump into the one question, right? So the question is like kth largest element, right? Kth largest element. uh, so the question actually is that you need to find, like if there's an array, right, you need to find the largest kth element, right? So as I said that if the question has kth, right, the question, you can see that question has kth and question is largest, right? So you will go to this kth plus largest, right? You will see this kth plus largest is min heap, right? Min heap. So you will I mean you will be like, okay, I will be applying heaps because these both terms are there, and I will be applying min heap right now, right? Min heap. So let's say why min heap, right? Okay, so this is min heap, and basically min heap min heap has the elements which are like the smallest elements are at the top, basically, right? Like when you're pushing, when let's say that there's some array 1 2 3 4 5, right? Or let's mix them. uh, let's say that we have some array 2 6 3 5, right? So whenever you are pushing into min heap, right, so this is just a kind of a stack, but you know, it just follows more rules, right? So let's say that you have pushed 2, so it will be 2 will be here, fine, that's fine, right? After that you come to 6, you will push 6, right? So instead of getting on the top of 2, it will be like this, it will be beneath 2, because min heap, it's min heap, so all the minimum elements will be like at the top, basically, right? So this is what min heap is like. Now putting 2 sorry, putting 3, what will, how, where will be 3 placed? Just below 3 2, and then this is how the placement will occur. Basically it will be in a descending uh, like from the top it will be descend in a descending way, like it will be increasing, right? Because min heap means the minimum elements will be at the top. So you, for min heap you can say that, let me just write that the smaller elements will be at the top, right? And these will be popped out first, right? Hence we will get largest left afterwards. So let me also explain this. I think kind of self-explanatory, but okay, I will still, like the first point you get it right, like the smaller elements will be at the top. You can see how, like 2 3 will be the smaller and 6 is larger, so it will be below, right? So and so like if you need to find out the kth largest element, right, largest element, so if you pop out all the smallest element first, you will get your largest at the top at some point, right? Like if you pop 2, then you will get 3, you basically wait. So if you basically pop out 2, so only 3 6 will be there. If you pop out 3, then you will get 6, so larger element will be stored beneath, right? Hence we need to basically just to remove all the smallest element that we don't need, hence we use min heap for the largest and max heap for the smallest, right? Same logic. uh, right. So now this is clear, right? So now we will also see one more thing, like you need to make a note of it, like all questions are sorting based, basically. in heaps. Please remember this, because uh, majorly questions that we will be doing, it would require some kind of a sorting. I will explain that, right? So like just let's just say that we have some array, right? Let's say we have some array 2 6 1 3 8 5, right? This is some array, right? And so like if your job is to sort them, right? So what will be the first approach? Like you can use merge sort, right? Like let's just start from merge sort. So what will be the complexity? Time complexity would be what? N log n, right? Let me write this in this way. O of n log n, right? Because you know, like merge sort, if you have not seen my video on that, please go and check that out. The video will be in this same playlist as you are watching right now, right? So merge sort o of log n, o of n log n, that will be the same, right? So basically what in merge sort we had to basically go to all the elements, right? Hence n is the there, right? So but if the question has given us some kind of a k, like if the question wait if the question k is given, like k is given. Oh, my handwriting in this pad is not that much good. Wait, just hold on. K is given, right? So if the k is given, if the question has k is given, then the time complexity should be what? We will explain that why. I will explain that why. So it will be n log k, actually log k, which is much better than this solution, right? So this is good, this is better, this is good, this is better, and this is like of log n. Basically if you we will do example, then you will understand what I'm exactly saying, right? So yeah, let's start from one question, right? Like we will be doing this question now. Fine. After this, you will get the gist of what exactly is a heap and how heap is basically helping us. Like why we are reading it, why we are studying heaps. So that's the whole point of this. Find the kth smallest element, right? So this is the question. Find the smallest kth element. Now for the identification part, you all know, if you see the k, basically if you see the k and you see the smallest in a question, what you have to do? Just apply heaps. Now judging heaps, what kind of heap you can apply? So we need to find smallest element, right? So basically we need to pop out all the largest elements, right? And if the largest elements are at the top, what does that mean? Excuse me. uh, so that is a max heap, right? If we need to pop out all the largest elements and the largest element at the top, so we will be using max heap. Excuse me. So sorry. Yeah. Yeah, excuse me. Yeah, so this is the, so we conclude that we will be using max heap, right? Now let's start the question. Like let's say we have an array, right? We have one array which is like 7 10 4 uh, 3 20 and 15, right? Let's go a little, yeah. So we need to find the kth smallest element, and question also has some k, which is 3, right? So basically in this we need to find the kth smallest element, like the third smallest element, right? So like what's the brute force of it? Like even in the interview, if this is asked, you always should start with the what? Brute force method, right? Please start from the brute force method, right? So let's say so brute force method, what will be that? So first you will sort it, like maybe using the merge sort, then you will get this array, right? After sorting you will get this 3 4 7 10 15 and 20, you will get this, right? And if we need to basically we need to get the 3, right? So basically we need to move to this element third, 1 2 3, and then you will just return this, right? So like what we did, we the time complexity of this approach would be n log n, right? N log n, because we like instead of sorting what is required, we sorted everything, right? We sorted the whole, basically we sorted the whole array, right? But if I say that that was not needed, you just did extra work. Let's say that if you needed this 7, why didn't you just sort these elements and then just, and these you don't ignore? Then what? Like, okay, sorting every element has costed you what? N log n, right? But if you have just sorted these, what will this cost you? N log k, right? Because k and k is 3 7, right? So we are just doing extra work right here. We are just like, by sorting every element, let me also write that, by sorting all the n elements, we are doing extra work, right? We are doing extra work because we don't need to. We are just concerned with the kth, like we just need to return the kth element, right? So why sorting the whole array? Like, so we we should be we should be concerned with sorting only till k elements and then just returning it, right? So uh, so for this we heap will be used, right? How we will see, let me now show you the exact way. Like, and if you do this, what you will make, like the time complexity, we will change the time complexity to low n of log n to n of log k, which is a great, efficient, which actually is a more efficient way, right? Clearly. So now starting with the stack, sorry, queue, oh, heaps, sorry, yeah, heaps. So let's say that, let me also write this again, 7 10 4 3 20 15, right? Now we will be using what, uh, heaps for this, right? So like starting from, I will explain you step by step, right? So we concluded that we will be using max heap, right? So the bigger element would be at the top, right? So putting 7, you have put 7, so yeah, it is good, 7 is there. And also you will keep a check of k, because you don't need to sort more than k elements, right? So we will be like, okay, we won't be putting more than k elements in this heap, right? So we will be checking if if the elements passes this k, right? Like, let's just assume that this is a glass, this has some water level, right? And you're filling water, but you can't exactly put all the water like above this level, right? So you'll be removing and all. So let's see what we'll do now. Pushing 10, right? Where will be 10 pushed in this? 10 will be above, right? Because 7, it is bigger than 7, and we are using maxi, right? We are using maxi right now, right? So now coming to 4, 4, where will be the 4 present? Also keep the check on k, right? You need to keep a check on k. Let me make it in some different color, right? uh, yeah, also keep a check of k, if it is more than less, no. In this case, what will be the scene? We did 7, we did 10, 4, now 4, right? So where will the 4 be? 4 will be at this, uh, 7 and 10. So we are exactly at the level, but still, let's move on, because yeah, if the now coming to 3, where will be 3 present? 3 will be here, 4, 7 and 10. Now k was 3, let me also write that so you don't forget. K was 3, you have just increased, right? So you can see that the size has increased k. If this is the case, then just pop, then pop, basically. right? This is the case, then just pop. So you will pop the element out, you will take the 10 out. So your new, basically your again uh, more new heap would be in this way, because you have just popped out, right? You don't need 10, right? So you have just popped out according to the our range. So 743, right? 743 you have popped out. So this done. Now 20, where will 20 come? 20 will come at the top, right? But again 20, if 20 comes here, 743, right? If this is the case, then we are again increasing our uh, basically we are again increasing the size, or again increase the k here, right? So this will also get popped out, exactly like and then we will start with the 15, because that's the last element. But again 15, if 15 also comes here, 743, if 15 also comes here, it is increasing the k, right? So again this will get popped. At last at last what will be the what will we get? At last we will just get this 743. We will see the arrays, the array is done, we are done iterating the array, and this is what is left. And so this, we will just pop out 7, which will be our main answer. Basically this, like the kth largest number would be 7 here, right? So this is how we will be solving, because you can see, you can analyze right now that using heaps, what we did, we removed all the non-concerning elements, right? What are the non-concerned elements to us? We didn't need 15, we didn't need 20, and we didn't need 10, right? And you can see, by just having the check and sorting it in a way, 10, 20, 15 were removed, right? They were popped, they all were popped. So this is the use case of this, right? uh, just hold on. Yeah, so this is the case, and now we will basically code as well, right? So yeah, starting with the code, I will also code. Now one note for this, like so like this is my opinion, but basically whenever you are like making heap, you usually do the heap tree method, right? Heap tree method, you can basically use the heap tree method. And in Java, that's the way, right? In Java, that's the way, but it is really uh, time consuming, right? Really time consuming, I mean, not by the efficiency, I meant by just writing all the heap tree, by creating the heap tree, it's really time consuming. So I would say is that to use STL in C++, it's a better way, actually, it's a better way. So you can use STL in C++, and basically it's like, even if you are doing Java, you can choose CPP for just doing the heap questions, right? That won't harm you. And as a developer, you should be comfortable with both the Java and CPP. Like, some things you just can't completely ignore one completely language. Like, if you are doing CPP, right, and in future you will require Java, if you are going in, let's say, big MNC which required Java somewhere in their microservice or something. So technically my point is that you can't ignore one language, right? So basically you need to be comfortable in both. And for heap, I would say that please use C++ STLs, right? I will show you why it is very easy, right? So we will be using one structure here, which is called as priority queue. Yeah, priority queue we will be using. Let me, so priority queue, we will be using priority queue here. And how we will be defining heaps? Yeah, so definition, let's see. Like, you just need to write basically, in first you will also uh, call the, in the headers you will call the STL also, that's required. And if you, let's say, if you need to basically uh, make max heap. So this is how you will be creating. So basically this means that this max heap will contain int data types of elements, right? So yeah, this is how easily you basically define max heap. There's one more way. There's one more thing you should remember, that if there's queue, if there's a pair, you can also basically, the priority queue, it can take these terms. And also there's also called as greater int, right? Int, which is a main heap, you can say, right? So basically this priority queue can take either int as a parameter, either vector, or as a, or either greater. This we will learn in future, but yeah, these are the things which you can get. Basically this means that you can also in future in later we will also see that instead of storing one element, we can store two elements as well. Yeah, two elements as well as a pair. Basically you will define a pair of int and int. If you're defined in this way, so basically uh, you are storing a pair which has both the parameters as int and int. So this is what pair. You can also store pair as well. And if you need to store pair, right, then you just need to replace int as what, as this, like, basically my whole point is that yeah, you can use pairs here, uh, right. But it's better to write, like, instead of defining it every time, like it will make your, this line very bigger, right? So instead of defining it in all the things, what you can do is that at the top, like outside the main, what you can do is that you can just write this thing like type definition. You can just define a type like int, right? Int, let's say that you have some int, let's say you have int pair of int comma int, right? And you can say that this is some ppi, right? And then instead of writing all this, you can just use ppi here, like greater ppi, vector ppi, right? So this is a better way of writing this, right? So this will be below headers, right? Like where the include statements are there, right? So this will be just below it, and in the main function or in the function call, you can just call this here, right? So that's the whole like definition, how you can define in CPP, right? Now we'll be back at the that kth. We will code for kth smallest element, right? uh, yeah, so basically we will be let's code for the kth smallest, right? So our main priority is to basically make a priority queue. I will use a priority queue, yeah, and which will have int, and it will be a max heap, right? Because you need to basically you need to get smallest term, you need to get all the largest terms out, right? So you'll be using max heap, because in max heap all the largest term are at the top, hence you'll be using max heap, right? So that's the whole point. So yeah, coming back to this, so we'll be looping. We can loop int I is equal to 0, I is less than the size, right? And I plus plus the size here is the of the max heap size, right? So if max h dot push, you can use this command array of I. If you are given this array, right, like let's say the function has array as an input, right, and k as the, okay, let me wait, I will just write this. Let's say we are given array, it takes array and int k, then that's the point. So if you are seeing uh, basically if you are seeing this max h, you are iterating, you will just push that in the heap, and now you will check if max h, you know, dot size, if the size of max heap increases k, right, if that increases k, then what, you will pop it out, right, because you can't store more than k elements in that heap particularly. So max h dot pop, right, you will pop it out and then just close it, you know, and then this will just return. You can also return, wait, after this I you can just basically return the top max h dot top element, which will be left after all the, you know, translations, right. So max h dot top, is it fine? Yeah, so this is the code. Now another question we will do right now, another different question we will do. This will be like it will be very similar, but let's also discuss this one. So you need to return k larger element, uh, in array. So basically instead of returning just one, you need to return k elements. Got it? So we will discuss that. Let me so let me take one more example for you, right. Let's say this is array of something you have. This is 7, 10, 4, 3, 20 and 15, right. This is the array and you are given as k as 3. So basically you need to your answer should be what, 20, 15 and 10, basically the larger element. So now judging that larger element, you need to basically have it here, right. So you need to pop out all the smallest elements, all the smaller element, right. And if the smaller element you need to pop out, which will be at the top, right. So what kind of heap you will be using? Will you be using main heap, right. You will be using a main heap. Fine, so let's use main heap and see what is happening here, right. So writing it here, right. So coming with 7 will be here, fine, because it's the only element, no time, no rearrangement required. 10 is bigger, so 10 will be coming above it, right. This is the case. Now this thing 7, 10, 4 is there, right. So 10, 7, 4, right, because this is a main heap. Please remember that this is a main heap, right. 4. Now what, 3, right. So also check, oh so sorry, also check k is equal to 3, right. So we can enter, right. Now see 10, 3, 4, right. So now 3 is there, so 10, 7, 4, 3, right. Oh so sorry, I did a bad mistake. Here the elements at the minimum will be at the top, right, not the vice versa, which I was doing. I was creating a max heap actually. My bad, it's fine, we will do it again, right. 7, starting with 7 again, and k you will be checking that, right. So now 10, so 10 is bigger, but you are using a min heap, right. So 7 will come above, right. So sorry, 7 will come above and 10 will be like this, right. Now 4, where will be 4 come? 4 will be coming above 7 and this will be a 10, right. Now k, check k is 3 and it is 3, so yeah, fine. Now 3 will come here, 4, 7 and 10. Now as k increased, you need to pop out 3, right. You will pop out 3, then you will get, basically you will get this stack, right. 4, 7, 10. Now you will see like why we are exactly using heaps, right. So now 3 is done. Now 20, you will get into 20, right. 20 you will see where will be 20 be placed, 4, 7, 10, 20, and you will see that this has increased k. So again you will pop out k. Are you observing something. We are now popping out all the smaller elements, right? And yeah, so this will be left 7, 10, 20. Right now, again we can push one more element, which is 15, right? 15, where will be the 15 get? 8. uh, 15 will be here. 10, 15 and 20. So you'll pop out this, you will be left with your final elements in the heap would be these 10, 15 and 20. These will be the final elements, and then you just return all them, exactly the same thing, right? You just return them. How you can return, how you can just write the statement, like after writing the for the min heap, you can just write like while min h dot uh, size is greater than min heap dot size, is greater than 0. Like if the size is not 0, then just keep returning. Basically, if you need to print out, let's say, you just keep cout min min heap dot top, top, and then just min h dot pop, basically, right? And just keep this running on the loop. Basically, this will do what? This will just keep printing out 10. It will just print out 10, which will be at top, and then just pop it. Then it will be the 15, print out, pop it, 20, print, right? So this is the whole point. And if when the size, the min h size has been 0, then it will stop. Yeah, so that's the logic. That's a simple logic here, right? So this is done. Yeah, so one more question we will do. This is a really important question, so please keep this. The question is, like, you need to now sort. Now basically, now you will be using a real case of heaps. You will sort an array, right? You will basically sort a k sorted array, right? K sorted array, as in, I'll explain it right here. Yeah, so what exactly is a case sorted array, right? So it's a really interesting kind of array. So okay, like before going that, let's see, we have this, right? This is a array given 6, 5, 3, 2, 8, 10 and 9, right? So basically, you just make a note of this, right? Elements which should in completely sorted array are within k element, are within k bounds, actually. How? Let's see. Let's say that we need to sort this array, right? Basically, this is given, this is some k sorted array. This is k is given as 3, right? 3. So if this is getting sorted, so what should be the first element here? 2, right? So 2 in this given array would be either at here, at this position, at third, in, like, basically the bound will be like 3. So 2 will be where the 2 should be placed, 0th. So from 0th position, 2 will be somewhere near 3 3 bounds. Like 2 is here, so it is exactly at third, but either 2 can be here or here, either 3 positions to left or 3 positions to right. 2 will be here, right? So at every element, let's say this, now 3, this should be 3, right? So 3 is like from here, 3 is just here, so it is within the 3 bounds, right? So this is the what this sorted array is. Right, now identification we will do, like how we can apply heaps here, right? We can do identification, but the brute force would be just to sort the whole array and then basically do it in n log n, right? N log n. But we don't need to do that because k is given, right? So identification, it is sorted, and sorted is basically corresponds to smallest here in this case, and k is given, right? So we'll be using heap, right? That's done. Be using, so we'll be use heap heap will be used, right? So uh, so basically what exactly we will do with heap, let me write that as well. So to put first, we just need to see k elements means array, not the whole array. Like starting from the 1 to put first position, right? We don't need to see the whole array. We can just see basically what I mean here is that uh, let me write this again. So to put first, like we need to see the third element. We need to see only these elements, right? 6 5 3 2. So this only these till 3. We don't, like, we know that the element which has to come at 0 position, it will be not away than third 3 positions, right? So it will be around 3 only. Got it? So this is the whole point of this, right? Now let's just apply min heap because we want to get the smallest, right? So uh, min heap, oh, you will see why in heap actually. Wait, just hold on. Yeah. So right, so this is the, what is the number we have here. Let me copy paste it. This is the number which we have, and we have 6, right? So first 6 will be placed here, right? 6 will be placed here, no problem. We are basically using a min heap, right? Right, so min heap. Now we will be basically placing again 5, so 5, simple, right? Now 3 3 5 6, right? Also don't forget to check if k increases or not. I mean, size increases the k or not. It is not. K is 3, by the way. Fine, k is 3. This k, right? So now doing it for the more element. So 2 3 5 6, right? Now you see it has increased k. So just pop it out, but where you will pop it out? In the sorted array only, because this is how sorted array, like we are sorting basically. The smallest element would be at the top, right? And we are using min. That's why I'm using min, because we are using the ascending order. We need to sort, right? So first element would be the smallest one, hence min heap, right? So that's the point. And as we go, we can also have, like, just for visualizing purpose, let's say that we have sorted array. Basically the answer, this is the answer only. So this is first, it will be empty, right? This will be empty. Just hold on, we do it in the color. Yeah, so this will be empty for now, right? Some elements. So starting with this, like from here we got 2, right? So we got 2. Let me make this here, right? So from here we got 2, right? So 2 will be here. Now again we will keep going with this flow only, right? So 8 will be there, right? So 3 5 6 8, yeah, right? 3 5 6 8 will be there, and hence since it is more than k, so 3 will be popped. 3 will be popped exactly here. So 3 is done, right? Now going with what? Now going with this more elements we will be putting, right? After this, what comes? 5, right? 5, 6, 3, 10. Basically, 5, 6, 8, 10. So 5 will be now pushed here, right? Because we are popping as the k is increasing, right? And uh, yeah, so basically this is how we will be sorting an array, right? So again, now 10 is done. So like in this way, what is left here? 10 is done, and 9. So 6, 8, 9, 10. So 6 will be here. 6 will be here. So similarly, we will get our sorted array as 2, 3, 5, 6, 2, 3, 5, 6, what? 9, 8, and 10. Oh, sorry. This is what we will get the sorted array, right? So yeah, so this is the whole point. Now we will just write the code as well, right? We'll just jump to the code part now, right? So let's start the code. So it's easy. We will be basically returning an array, right? So I will describe a function which has the array, and we are passing it an array, right? And in 10, where it is a size, and k, which means a k sorted array, right? So int vector int ans, right? And priority, and we will be also declaring a priority queue, right? Which will have int as it will have int vector, you can say vector int, you can say greater, I mean you can define anything. I'm just writing it for your convenience, but we will be basically be describing a min heap, right? Now for int I is equal to 0, I is equal to 0, I is less than n, and I plus plus, right? This is the whole point. So min heap dot push, basically we'll be pushing as we are going, right? We'll pushing the arrays, right? Now if min heap dot size, is greater than k, what you have to do? You need to push it in the ans array, basically, right? Let's say that ans array is the basically which we need to return. So push back, it's a vector, so we will be using push back, right? So push back what? Min h dot top, right? And after you have pushed back, just pop it out from the min heap, right? This is done. This is done. Now now you need to basically return the answer, right? So min dot size, because it would be some elements would be left, right? If they are left, just push back them as well, push back them as well, right? Which will be at the top, right? Each element will be at top, and as you are pushing, keep popping out, and this will run till the min heap is empty, and return uns. Basically, you just return the formed what we say formed a vector, right? So this is the code for this one. Got it? So simple code, nothing much. Now we will be doing one more question, which is yeah, here you will see like how we will be how kth largest, how we can also use pairs inside the heaps, right? So clay closest number, this is the question. This is basically the question. Let me make it bigger. K closest number, right? So basically easy. What we want to what exactly question says, let's see. Let's say that we are given array, we are given an array which is like 5 6 7 5 6 7 8 9, right? And k is given as 3, right? So an x is given some 7, basically the closest number to 7, right? Yeah, so I mean, we need to find the closest number to 7, like three closest number to 7. So it will be 6, 7, 8, right? Because 7 will be included. Just before 6 it's there, and 8 is also there, right? So three elements. How we'll do this? The brute force method is also is a nice method, but yeah, it is basically it has high complexity. So let's say that we are 5, 6, 7, 8 and 9, right? 8 and 9, this is 8, right? So we can, what we can do is that we can subtract minus 7, minus 7, minus 7 and minus 7 from each of the element, right? What we will get here? 2, 1, 0, 1 and 2. And then just, you know what you do, you just basically sort this 0, 1, 1, 2, 2, and then just return these three and their correspondence numbers, which is like 6, 7, 8, right? So this is what the answer is. This is what will be the answer. This is the brute force method, because now we are basically iterating to all the elements, right? And 7. But why we need to iterate to all the elements? We don't need this, we didn't need we didn't need this one and this one, right? So why did we iterate through all this? Why did we do this operation, this and this was not needed, right? Not needed, not needed, right? So hence we will be using heaps now, right? So yeah, now we know like why we did use heap, like why heap is required basically. So to solve this, first we will see one question, and like one question which we earlier did. I just want to make one relation, like, so in kth largest, when we need to find the kth largest element, right? So what we did, we took a min heap, right? We took a min heap and we placed some elements. The largest ones were at the top, which got popped. Sorry, the smallest one which got popped, smallest got popped, right? And we did return the kth largest number. But here in this case we need to basically return all these elements, right? So it's kind of like all these elements, 6, 7, 8. Instead of returning just the largest 8, we want to return all these elements. So we know that we will somehow use this approach only. Min heap will be involved somewhere, and okay, let's see what will be involved here exactly, right? Now yeah, so basically we are sorting the differences, right? We have to sort the difference, and we need to track them, right? So uh, here we need to keep a track of both the things, right? Basically in this heap, what we can do is that we can have two things, right? We can have a key pair, we can have a key, right? And also we can have this difference, right? So this, like, we can have a pair difference, and this will be a correspondence number, right? Like to whatever number is like in the array, right? Also keep a note of that. If we are putting, like, I will just write it, if we are putting pair in a heap, the heap will sort itself according to the first number in, I mean first element in pair. Got it? So basically right now you need to know this, right? To solve this question you need to know this thing, right? This thing. So basically if we put things in array, right? If we are putting some things in a heap, right? And we know that the first thing will be how it will be sorted, right? And now what we were sorting, basically we were sorting the difference, right? We were sorting the difference here. See here, we were sorting the difference. So don't you think that differences should come here, like 0, 1, 1 basically, right? So differences would come here, and what we need to return the numbers. So corresponding number will come here, right? So we will have a pair basically, right? We will have a pair of basically this will have this and this, right? So I will just write it here. We will have an absolute, we'll have an absolute difference, right? We will have a absolute difference in this pair. Like we will okay, wait. We will have a absolute difference of array of I minus x, right? And this will be, and here in this the second pair would be simple array I, right? Only this array I would be there. So this will be the pair basically. So we will be defining our pair in this way. Basically, uh, pair int of int, right? Like, didn't I say this, right? We can say priority queue, pri priority queue, and which will be something like this, which will be a max heap, because the smaller number are below, right? And we need to pop out all the max numbers, so this will be our max heap. So got it? So this is how we will be, this is the reason why we are putting a pair and all, right? So now doing the iterations and all, right? Let me show you guys now, right? So let's say that we are starting, right? And we have 5, 6, 7, 8 and 9, right? So and x is 7 and k is 3, right? So 7. Now if we consider 5, so 5 minus 7, 2, which will be 5, right? Now this is also a max heap, and we will be sorting the heap, get sorted at the first number, right? According to the first number, please remember that. And k is not reached yet. Now putting for 6, so 6 minus 7, 1 comma 6. So 1 comma 6, where it will come? It will come below, right? Because it's a max heap, so maximum number 2 will be above 1 comma 6. Basically this is what we are iterating, right? Now coming to next number, next pair, which will be 7. So 0, so 0 minus 7, 1 minus 6, 2 minus 5. Got it? Again 8, which is what? 2, right? No, sorry, 1. So 1 comma 8, right? 1 comma 8, 1 comma 6, 0 comma 7, and 2 comma 5. Now since it has increased, the size has increased, the k, you just pop this out, right? And then again last number 9, which is again 2 comma 9, 1 comma 8, 1 comma 6, 0 comma 7. Again you will pop this out. You are left with what? You are left with these three numbers, right? 1 comma, these three pairs basically, 0 comma 7. So you'll just return first pair, I mean first, sorry, not the first, second. Basically you want to return 8, 6, 7, right? So you just return second from pair, right? So yeah, that's the logic, that's how we will be solving this question. Simple. Got it? So yeah, so basically we just got introduced with this concept of adding a pair, and we just like, we need to basically sort the difference, and we want to have this relation that this is corresponding, this is some, linked with this, 0 is linked with 6, right? So that's why we are using a pair, right? So hence we will be now we will be coding this, right? So I will just write a quick code. Okay, so priority queue, okay, priority queue, which will have a pair of int and int. Got it? Which will be called as p, let's say p. And for int I is equal to 0, I is less than size, and I plus plus, right? So max heap, you are also, you have defined max heap, right? So max heap dot push, you need to push absolute of array of I, right, minus x it is given, and array of I. Basically we are just pushing this, right, this pair. So if max h uh, wait, we can have like this, it needs to be in this way. Fine. So max, you can also define a type function, but type definition, but okay. Max dot size, if the size has increased the k, what you need to do, max h dot pop, simple pop, and then whatever elements are left, like after all the bigger elements are popped, and if they are still left, what you need to do, simple, you need to just see out all the second terms, right? So max h dot top, right, dot second. By writing this, you will get basically you will get what you need, the second element, and as you go, keep popping out, right, and then done. This is a simple code, so also keep a note that in a heap, like, it is not always that we just need to push numbers. We can push anything, right? In a heap we can push any key basically, right? Yeah, I mean, like frequency, basically the questions which requires frequency or difference, you can put anything according to the need. So please, you can use this relation when solving any kind of question. So please take a good look of it, good note, note this out. And hence I'll be giving you homework now, right, which is homework. Please note about the homework. So your homework would be like, you can use the exact same concept which I told you. It's really easy. So frequency sort, you should do frequency sort, and k closest points to origin. This is also a good question which you should try after frequency sort. Fine. So please try these both questions as a homework. Right. So one last question we will doing, which is actually really interesting. Like, this is like a star question, So connect ropes. The question goes like, connect ropes. Got it? I will explain that to you. So basically, let me write the full question only. I mean, just not the keyword. Like, you need to minimum cost of connecting ropes. Basically, this is the question. I guess this is actually really asked in coding rounds basically. So please make a note of this. Let me explain that problem to you now. Let's say we have array, right? We have an array which is goes like 1 2 3 4 5. For simplicity, let's just take this array, right? And these are basically the lengths. These are the lengths of wait, these are the lengths, right? Lengths of ropes. These are the lengths of the ropes. So it starts from 1, 2 3 4 5. Just imagine it like, this is one rope, right? This is second rope, this is third rope, this is fourth rope, and this is the fifth rope, right? Now we need to let me write this. We need to minimize the cost of connecting these ropes. And how is this cost, like how the cost is getting calculated, right? Simple. If you connect these two, like 4 and 5, if you connect these two ropes, okay, let me just draw it a little better. Fine. So how is the cost getting calculated? Let's say that you connect these two length of ropes, right? So 4 plus 5, 9. So the cost would be 9 only, right? This will be the cost. So connecting of the two ropes of the given length will be the cost, right? So length will be also 9, but the cost is also 9. So yeah, let me just show you how you can basically do some kind of operations, right? So let's say that 1 2 3 4 5, right? So let's say that you connected you started from these three, right? 3 4. So what is 3 4? You will be like 7. Fine. And as you are connecting, also write the cost right here. In this cost, you are maintaining this. So as you connected this, the cost will be 7, right? 7 plus. Now you connected like this and this, right? What you'll get, 7 plus 2 9, you'll get 9, right? So also write 9. This is how the cost will get calculated, right? Now you will be like okay, 9 is done. Now 9 plus 5 give you what, 14, right? 14 here. And then finally 14 plus 1 will give you 15. So plus 15. And the total cost in this case would be what, 45. It would be 45, right? So you see that if you connect in this way, like first 3 4, then this in some kind of way, your cost will be 45. Now let's connect it in some different way. Like this is how you should try out all the solutions and then see the pattern, right? Like let's say 1 2 3 4 5, right? Okay, fine, let's start from this, right? 1 2. So this will be 3. And also write the cost, 3, right? 3 plus. Now 3 plus 3 gives us 6 plus 6. 6 plus 4 give us what, 10, right? Plus 10. Now 10 plus 5 15, plus 15, which will give you it will give you actually 34 basically, right? So are you seeing? So the length, like the total length would be 15 only, because you are ultimately adding all the same numbers, right? But the cost, the way which how we connect, the way how we start, that is changing, right? 45 in this case. In this case it was 34. So we need to try out all the combinations and basically return the minimum cost that is require, like that is possible, right? Now one more way, which is actually the answer, right? So let's say you tried out all the combination and then you also tried out this, right? 1 2 3 4 5. Now you are like, okay, I will basically I will start, I will not exactly follow the same thing. I will just take the minimum lengths, right? Like 1 2, and you can also add like 4 5, right? So 3, this is 3, this is what, 9, right? So 3 plus 9, and then you can add 3 3, which will give you 6 plus 6, and then 6 plus 9, which will give you 15, which is 15. And now this will come out to be 33. And this is what the answer is. This is the minimum cost that you can get by adding all this, right? And yeah, so this way you basically you just shows the smallest numbers which is possible, right? So here, so this is what now we need to like basically just see how we can get to this, right? So we can conclude basically, right? So at any time, what you can do is, at any time uh, we need to basically add ropes which are minimum, right? And also take a note, like here also we added the ropes which are minimum, right? For like 1 2 we started, right? 3, and then we are like, okay, what is the minimum now? Instead of just going with 6, right? Like see, I could have done I could have actually done some other way, right? But we wanted minimum lengths, right? So minimum lengths I chose. So that's why at any time we need to add rows which are minimum, right? And this is also a good, there's also one good point, like in questions where you need to get optimal cost slash solution, please pick up minimum elements or any minimum elements or parameters. Got it. So this is one takeaway you can, use, right? You can use a similar way if the question asks for optimal cost or solution. This keyword is really famous. So then you can use this way, right? So let's see how we can solve this, right? uh, yeah, so let's say uh, we have a min heap, right? Because we need a let's see why we are using a min heap as well. So let's say when min heap, and we are adding one, and similarly we just added all the elements, right? And there's no k for now, so just add all the elements. What will be the min heap? 1 2 3 4 5, right? This is the all the elements will have this way, right? Now you need to basically add the numbers, like the top two numbers you can add, right? What will be the addition of this? 3, right? And as you're adding, you can have one total cost as, just a array, and this will be 3. Like first you added these top two numbers, right? So this will be 3 plus, right, the 3. Now you got 3, and then just again, like pop these out. You can, pop the both numbers out, add them, and then just put them back again. So this will be 3 3 4 5, right? This will be 4 5. Now again you do the same thing. 6, pop these out, add, and then just again put it inside. What will you get now? 4 5 6, right? Why we are using min heap now? You get the point, right? Because the we need to basically add minimum. See, in this question we need to add ropes which are minimum, so minimum ropes will be at the top. If we want to do any kind of operation, it will be the elements should add with the top, and those would be a minimum, hence minimum heap, right? So 3 6, and as you're adding, like as you're getting them, also add it to the total cost, right? Now what now you add them. 4 plus 5, right? 4 plus 5, 4 plus 5, which will be 9, right? So 9, put 9 6 9, right? Also add 9 here. Now last 6 plus 9, which will be 15, right? So you can add 15 here, and hence you get what. And if the, if the queue is empty, then just return whatever the total cost is, which is what? 33. Got it? Yeah, so this is how we'll be using doing this question. So it's really good question. Now I'll just quickly get to the coding part now, right? So yeah, so let's say let me start the coding. So you can define the min heap. Let's say you have defined using min heap, min heap, right? So you can define a min heap, right? Now while min heap dot size is greater or equal to 2, right? Because we need two elements, right? So yeah, that is the, because we need to add them, right? So we need that. So let's say int first is equal to min heap dot top, right? Then pop that, as if you got the first element, min heap dot pop it, right? Then you need to find second element, which will be, it will come as you pop, it will come again. So that will be the top one, right? And then again what? Min heap dot pop, as I said, right? Then what? Your cost would be cost plus first plus second, right? Because this cost, like currently the cost is 0. You can also define cost int cost is equal to 0, right? So currently the cost is 0, and as this loop goes on, the previous cost will be added also, right? And also as you're calculating, push it like the first plus second, right? And yeah, and then just return cost, as if the basically when this gets empty, just return this, right? Got it? So this is what the concept is of it. Yeah, this is the code, and yeah, so this is what we will be stopping right now. I wanted to cover hashing also, which will be in separate video. Fine, separate video. So yeah, please practice all the questions which we'll be providing in the assignments, right? You can also ask ask your queries ask your queries in our telegram channel, right? telegram channel Telegram channel, you can ask our queries, and if you have any doubts, please let me know. We will be covering in the next class now. So yeah, thank you all, and see you in the next class.